In the desert silence of New Mexico, in a decade that still smelled of war, a new kind of weapon was being reborn as a tool of peace. The year was 1955. The Second World War had ended only 10 years earlier, yet its ghost still filled the laboratories of both the United States and the Soviet Union. From those ghosts came the idea that man could finally touch space. For America, that dream began with a name few remember: Project Vanguard, a name chosen to sound harmless, scientific, and civilian. But beneath that calm surface was a struggle for pride, power, and survival. The story of Vanguard starts not at Cape Canaveral, but in the ruins of Germany. When Nazi Germany collapsed in 1945, Allied soldiers discovered hundreds of V-2 rockets, the world's first long-range ballistic missiles. They also found the engineers who had built them. Among them was Werner von Braun, the man whose team had turned wartime terror into technological revolution. Both the Soviet Union and the United States rushed to claim these mines. The Soviets took what they could from Eastern Germany. The Americans secretly brought more than 100 German specialists across the Atlantic under Operation Paperclip. They would work first for the Army, building and testing captured V-2s in the deserts of New Mexico. Each launch rose higher than any weapon before, each one carrying instruments instead of explosives. The boundary between war and science was already blurring. Yet in Washington, a different vision took shape. President Eisenhower wanted space to look peaceful, not militarized. He feared that if the first satellite came from the Army, it would be seen as a weapon in disguise. So in 1955, he approved a plan led not by generals, but by scientists from the Naval Research Laboratory. Their task: build a rocket capable of putting a small scientific satellite into orbit. They called it Project Vanguard, the first step of a world scientific effort known as the International Geophysical Year, 1957 to 1958. Its goal was to study Earth's atmosphere, magnetism, and cosmic radiation. The Americans hoped their contribution would be the first artificial satellite ever placed in orbit. The rocket itself was a fragile three-stage design. The first stage came from the Navy's Viking missile, burning kerosene and liquid oxygen. The second stage used the new Aerojet AJ-10 engine, running on storable nitric acid and unsymmetrical dimethylhydrazine. The third stage, a tiny solid fuel booster, would provide the final push to orbital velocity. No system like it had ever been built before. From the beginning, Vanguard was under pressure. Every piece had to be developed from scratch. Unlike the Army, the Navy team was forbidden to use proven military rockets. Every nut, every valve, every circuit had to be civilian. Delays stacked up, budgets strained, and somewhere behind the Iron Curtain, Soviet engineers were already testing their own giant rocket, the R-7 Semyorka. By the summer of 1957, both sides were racing the clock. The Soviets worked in secret. The Americans worked in the open. Their failures visible, their deadlines public. Technicians at Cape Canaveral prepared the first full Vanguard vehicle, tall and slender, painted white against the blue Florida sky. Its payload, a small aluminum sphere only 16 centimeters across, weighing barely 1.5 kilograms. Inside were tiny transmitters that would send back a simple radio tone. It was meant to be humanity's first voice from space. But on October 4th, 1957, that voice came from somewhere else. The Soviet Union stunned the world with Sputnik 1, a polished metal ball broadcasting its eerie beep beep across the sky. The news reached Washington in the middle of the night. Headlines the next morning shouted, "Soviet satellite circles globe." The space race had begun, and the United States was losing. Vanguard suddenly became a national emergency. Politicians demanded results. Newspapers demanded explanations. The team that once moved carefully now worked under impossible pressure. Engineers slept in the blockhouses. Mechanics skipped meals. Every delay looked like humiliation. December 6, 1957 was supposed to change everything. Crowds gathered around televisions. Reporters filled the Cape Canaveral press stands. Cameras pointed toward the shining rocket standing tall on Launch Complex 18A. At 11:44 a.m., the countdown reached zero. Engines ignited. For a split second, Vanguard lifted gracefully from the pad, just over a meter into the air, then suddenly lost thrust. It hesitated, almost hovering. before sinking back down into its own fire. The fuel tanks ruptured. A white-orange explosion tore across the launch pad. The satellite, thrown clear, rolled a few meters away and began to beep softly, still alive in the flames. Within minutes, the disaster was broadcast worldwide. The Soviet press mocked it as Flopnik, Kaputnik, and Stayputnik. To the American public, it felt like a national embarrassment. Cartoons showed rockets collapsing, while Russian cosmonauts laughed from orbit. The humiliation was complete. But in laboratories and hangars, no one laughed. The engineers studied the wreckage piece by piece. They discovered that a simple fuel line had ruptured under vibration. It was not incompetence. It was the cost of trying something entirely new. In the months that followed, the Vanguard team refused to surrender. They worked through nights, replacing pumps, rewiring guidance systems, strengthening every joint. Each test was a lesson. Each small success repaired a piece of broken pride. Meanwhile, on the other side of the country, the Army team under von Braun was growing impatient. They had a rocket, the Jupiter C, ready to fly. In secret, they prepared their own satellite. When the government finally gave permission, they launched Explorer 1 on January 31st, 1958. America was in orbit at last, but not through Vanguard. For the Navy engineers, it was bittersweet. Their project had become the nation's scapegoat. Funding was cut. Journalists called it obsolete. But they kept working. They believed their small satellite could still prove something important. March 17th, 1958, 7:15 a.m., Cape Canaveral again. The new rocket, Vanguard 1, stood ready. No television cameras this time. No cheering crowds. Only tired faces behind consoles and a handful of observers. Engines roared. The rocket rose cleanly, leaving behind a trail of blue flame that stretched for miles. At 403 seconds, the final stage fired. The tiny sphere separated and slipped into orbit, 3,970 kilometers above Earth. The United States had finally succeeded. The satellite began transmitting its faint rhythmic beeps on two frequencies. Those tones carried data about temperature, battery voltage, and orbital decay. For 7 years, Vanguard 1 kept speaking. Its signals helped scientists map Earth's shape with unprecedented accuracy, revealing that the planet was slightly pear-shaped, bulging at the equator, flattened at the poles. Even after its batteries died in 1964, the satellite remained in orbit, and it still does. The oldest human-made object circling the Earth, more than 65 years later. Behind that tiny success lay massive consequences. The humiliation of the failed Vanguard launch had jolted Washington into action. Within months, President Eisenhower signed the National Aeronautics and Space Act. On July 29, 1958, NASA was born. Most of the Vanguard team were quietly absorbed into it. Their tracking stations became the backbone of NASA's global network. Their test data guided future rockets, Atlas, Thor, and eventually Saturn. In that sense, Vanguard's explosion became the foundation of America's future in space. Without that failure, there might never have been a moon landing a decade later. The public, however, soon forgot. The space race moved quickly. Yuri Gagarin, Mercury, Gemini, Apollo. The names changed, the rockets grew larger, the stakes higher. But inside NASA, veterans of Vanguard remembered those early mornings on the Cape, when a handful of engineers tried to reach orbit with slide rules, oscilloscopes, and hope. They remembered soldering wires by hand. They remembered the static of a radio tone echoing across the control room. They remembered the silence after the explosion. And they remembered the second launch, the one that finally worked. For historians, Vanguard marks a boundary. It was the last American space project born outside NASA, and the first to use computers for trajectory prediction. Though those computers were still women with calculators. It was also the first program to prove that failure could be broadcast live and still lead to progress. Technically, Vanguard 1's orbit is so stable it could remain aloft for more than 1,000 years. When everything built after it has fallen back to Earth, that little aluminum sphere may still be circling above, carrying within it the fingerprints of the engineers who dared to try. Look closely at photographs from the time. The launch tower leans against a pale morning sky. The rocket looks impossibly thin, as if one gust of wind could topple it. In black and white footage, the flames at liftoff look ghostly, almost transparent. Every sound echoes, valves hissing, telemetry chatter, the countdown voice crackling through static. Then the brief moment of triumph, a trail of smoke, a signal detected, a room exhaling at once. That sound, the quiet beeping of Vanguard 1, was not just a technical success. It was a declaration that the United States had entered space, not only with weapons, but with curiosity. The satellite carried instruments to study the density of the upper atmosphere and the influence of solar radiation. Those measurements became the basis for understanding orbital decay, crucial for every mission that followed.